Is it working? Yeah. Hello? Okay. Hello? Okay.
Oh,
welcome everybody. Can you hear me? Welcome everybody to this year's summer school. Last year we celebrated our 65th anniversary, so this is our 66th year. And I need your assistance, Mr. Eddie.
oh, sorry, ma'am.
It's not loud enough. Thank you. Is that better? So welcome everybody once again. It's going to be very hot today, and I wish you good luck in coping with the heat. We certainly are facing quite a number of challenges as staff because we've been kicked out of our regular premises. They are renovating the lecture rooms in Kramer, and I hope you find the change in very not too disconcerting and not too disorientating. I'm sure most of you have been used to being down at Kramer. Parking can be a bit of difficulty. So, yeah, we all just have to be, and especially with this heat. Okay, so let me then waste no more of your time and introduce Dr. Samantha Brooks, who is going to talk to us. Samantha is a senior researcher at the Department of Psychiatry and Mental Health. Her research specializes in the role that the neural circuitry in the brain, in our brains, play in what she calls impulse control. And she's interested in using this research to try and understand, for example, problems like addiction and eating disorders. And also, she completed her PhD at the Institute of Psychiatry, King's College in London, where she learned clinical neuroimaging techniques. And Samantha is going to explain in the course of the lecture what neuroimaging techniques are. I'm not going to try and attempt to explain. I looked it up at Wikipedia, and after the first paragraph I was lost. So I'll leave it up to her to explain. Samantha also then, after her PhD, she did a postdoctoral fellowship at the Karolinska Institute at Uppsala University in Sweden. She has published very many papers, over 50 research papers in this area. She is still working in collaboration with her colleagues at Uppsala University. She's hoping that her work on impulse control in eating disorders and addiction will improve our understanding of the brain processes involved in cognitive control, in other words, willpower, so that people with impulse control problems can be trained to improve their self-control and ultimately lead more fulfilling lives. So, Samantha, we welcome you, and we hope we can all improve our lives.
Thank you very much. Can you hear me? Okay. Is this loud enough in the back? Yeah. Okay. If it stops being loud, let me know. Thank you for welcoming me to your summer school series. I noticed that a lot of people, when we talked about willpower just then, seem to encourage me to convince them that I'm going to be able to convince you to strengthen your willpower. My belief is that we are all addicted to something. I shan't tell you what my addictions are. But whether it be eating too much chocolate, that's my addiction, or other more harmful things. I think we can all benefit from learning how to strengthen our brains. So, without further ado, please, if you've got any questions as I go through, please put your hand up and I can answer them. And if I'm going too fast, because when I get excited about my research, I often talk too fast, so please ask me to slow down. Okay, so the title of my talk is Addiction. What can neuroscience tell us about it and how to make people better? But before we start, who the heck am I? As you can hear, I'm not South African, although I'm trying to become adopted by your wonderful country. And whenever I go home to London, I ask my colleagues and friends, do I sound South African yet? Because I love your accent. It sounds like Queen's English. And they say, no, but you do say ya a lot. So yeah. So who am I? So this is me, this little person here, 6-year-old, I think, at a party. I was completely scaring this poor little boy. I was born in Northamptonshire, in the middle of England, and in a farming community. Then I moved down to London to complete my PhD. I have spent a good sort of 10 years studying and researching the neural correlates of eating disorders, and then now in Cape Town branching into addiction. And you might wonder, what is the link between eating disorders and addiction? More than you would perhaps think, but specifically my research is trying to look at the what we can learn from the anorexic brain. And the anorexic brain, and this is what I studied in London, is very good at controlling something that we all need, which is food. So they do it too well, to the point of almost death in some cases. But we can learn something, is my belief, from the people who have eating disorders, particularly anorexia. So that's what I did at King's in London. And then, as was mentioned earlier, I then went to Sweden to do a postdoc to continue looking at adolescents with an early diagnosis of eating disorder. And I'm glad to be here and not in Sweden at the minute, because it's minus 35 in Sweden. So a very different extreme. And then I came to wonderful University of Cape Town, and I've been here now for just over 3 years. I can't believe it's gone so quickly. Studying the brain. Working with some wonderful students. I can't see any in the audience at the moment, so they're obviously still in bed, maybe, or working on my papers, our papers. And what else do I do in Cape Town? I climb lots of your wonderful mountains. So that's me, yeah. So what is addiction? So I apologise that this is a bit greyed out here, but this is the outline of my talk. So I'm going to tell you a little bit about what addiction is, the neuroscience of addiction, the neural effects of standard and novel treatments, some recent work from us in UCT, so hot off the press work, some data that we've got recently, some brief conclusions and future directions, and some follow-up work for Wednesday. So what is addiction? What does addiction look like? This is quite awful to see. I mean, this person here is, well in control, and the person on the right-hand side here has lost control. It does feel like this cartoon, I think. I've never, luckily, been addicted to substances, drugs, but it must feel, you're dying to be satisfied by the drug of your choice, to the point where you just lose all will. The only thing that's important to you is taking the drug, to the point where you don't care about your appearance anymore, and you gamble away all your money, and you forget about your future goals for happiness and your family. And to the point where it's very damaging to your health as well. And it's very awful, kids that are starting these habits early because their brains haven't fully developed yet. So a little bit more formal then, what is addiction? According to the Diagnostic and Statistical Manual version 5, which is the Bible of psychiatry, it says that the notion underlying addiction, and I have to say there's not too many heavy slides with lots of text, but I think it's important to give you some formal information. So the notion underlying the addiction concept is that the substance use or behaviour originally intended for pleasurable recreation is now compulsively driven, so they have to do it. Substance-related and addictive disorders are classified by the DSM as mild, moderate, and severe. So you can have a mild substance use disorder. But the DSM-5 no longer uses the term abuse and dependence, because that's pejorative in a way, but the term use. So substance use disorder is the correct way now to classify addiction. And substance use can include alcohol, stimulant use, nicotine. So some of those are more socially acceptable than others, obviously. And then you've got behavioural addiction, so gambling, internet use, sex, but also dependence we have to veer away from now, because dependence is not the same as addiction and can be a natural bodily response. For example, we're all dependent on nutrition, on air, on water. So dependence itself is not addiction, it's use, mild, moderate or severe. Another slightly heavy slide, but substance use disorders occur when the recurrent use of alcohol and or drugs causes clinically and functionally significant impairment, such as health problems, disability, and failure to meet responsibilities at work, school or home. And according to the DSM-5, a diagnosis of substance use disorder is based on, and this is the most important point I think, is based on evidence of impaired control. This is a really crucial point, impaired control. Then social impairment, risky use, and pharmacological criteria. So the notion of impaired control is going to come up a lot in these definitions. And the substances that are included in disordered use are obviously alcohol, tobacco, cannabis, and in Cape Town this can include Daka, Mandrax, marijuana. Stimulants, which include methamphetamine, that increase your feeling of likability and social ability, cocaine, hallucinogens, LSD, and opioids such as heroin that make you feel good. Excuse me. Conversely, behavioural addictions, besides psychoactive substance ingestion, produce short-term reward that may engender persistent behaviour despite knowledge of adverse consequences. So you have to keep doing it. Diminished control, there it is again, diminished control over the behaviour. These disorders have historically been conceptualised in several ways, and one view posits these disorders as lying along an impulsive compulsive spectrum. That's another important term, impulsive compulsive. So it's not only impaired control, but impulsivity and compulsivity. These are important words. So as lying along an impulsive compulsive spectrum, with some classified as impulse control disorders. And so another conceptualization considers the disorders as non-substance or behavioral addictions. And behaviours include pathological gambling, hypersexuality, internet use. I mean, so many people today can't go without checking their Facebook every 10 minutes. Shopping, binge eating, and I've put a question mark there because there is a theory that obesity and overeating is an addiction in itself. Over-exercising can also be an addiction, body piercing, these kind of behaviours. So I mentioned that impulsivity and compulsivity are also very important terms in the addiction definition. So what is the difference? It's often difficult to say. Well, this is very important to keep in mind as we go through the talk. So impulsivity is essentially, there's little thinking involved. It's a knee-jerk reaction. It's automatic, non-conscious. For example, binge eating, drug taking, and aggression. Afterwards you're conscious of it, but during the binge or the aggression or the drug taking, you're not really there. You're not really present. Compulsivity, on the other hand, there is thinking involved, but it's consumed by a desire to obtain a substance or engage in a behaviour. You can't think of anything else. Your whole life is consumed by this thing. It's like being in love, almost, isn't it? Obsessions, cognitive biases for that particular thing. So impulsivity, little thinking, very knee-jerk reaction. Compulsivity, more thinking involved, but it's more about rumination. So, let's get on. Yes?
Can you clarify about why obsessive-compulsive disorders themselves aren't
Well, obsessive-compulsive disorder is a comorbidity in addiction, but it's slightly different because it's not substance. It's behavioural, that's true, but it's more of a non-sort of behaviour. You're not trying to consume something. It's a byproduct. It is a comorbidity, but it's a behavioural pattern. So it could be that you're just OCD. You're just compulsed. You're driven to do something, but there's not necessarily a stimulus in the sense of, if you've got a behavioural addiction, it's you're gambling, you're trying to achieve something, you're trying to get more money, more reward. Internet addiction, you're trying to consume something, but with OCD itself, it's more about anxiety reduction. It's more about reducing the anxiety itself. It's classified in the DSM as an anxiety disorder. So it is comorbid, which means it's often when people are addicted to something, they've also got OCD, but it's classified as an anxiety disorder to reduce anxiety. Very similar. Yeah. So we're going to come on to the heavier stuff of the talk now, so the neuroscience of addiction. So please stop me or ask me questions if I get too heavy. So the one thing, actually, before I start, the handout that I gave you is very, very heavy as well, but I'm hoping that please, do read it over the next couple of days, and hopefully some of the concepts that we talk about or that we discuss in this lecture will help you to understand it a bit more. But please don't get too worried and skip over some of the things that are a bit more complicated towards the end of this handout. And you'll see later that the homework essentially is to go through this, and anything that doesn't make sense, we can talk about it on Wednesday. So some of the theories that are mentioned in this handout are these three: Pavlovian conditioning, which some of you might have already heard of, instrumental conditioning, and opponent process theory. So these are three theories that are quite prevalent in addiction research. So Pavlovian conditioning. Hands up who's heard of Pavlovian conditioning? Brilliant. So pretty much everybody's got a background in psychology. So we all know that it's all about stimulus response. So you have an unconditioned stimulus. In the case of Pavlov's dog is food. You have your conditioned response salivation, which then becomes eventually paired with a conditioned stimulus and the conditioned response. And this is very important for addiction, because it's linked to this very passive link to the substance that you become addicted to. And the difference between classical conditioning or Pavlovian conditioning and operant conditioning is that in operant conditioning you have to do something. So you now have to press a lever, you have to do some kind of behaviour. So now you're learning that your response is going to actually lead to a particular reward. So that's the main difference. And it's very important also to think about these differences because they do represent different brain processes. I'll talk about that in a moment. And then the third sort of prominent theory is opponent process theory, which was developed by Solomon back in the 70s. So it's quite an old theory, and it's a theory of motivation which has been sort of pilfered for addiction theories. And basically it suggests that hedonic states, so we do things that make us feel really, really good, but they're modulated by a flip side of the coin. So anything that makes you feel good will have a down effect. So you get something, you get chocolate, you eat your chocolate bar, and then later you might feel a little bit depressed. You do lots of exercise, and if you stop doing the exercise, you get a little bit, maudlin. So euphoria might be countered by depression, for example. So what comes up must come down. And unfortunately, the more positive feelings you feel, so if you become sort of mania-driven, the more tolerant you feel to them. So in the case of addiction and substance use disorder, the more drug you take, the better you feel, the more tolerant you become to it. And this causes anxiety and depression as a down side. So the more your central nervous system will seek to counter them with negative feelings. So the aim, in a way, in psychology, I think, is to keep a balance. And I'll show you a spectrum model in a while that suggests that, you know, normality or normalcy is kind of in the middle, keeping a balance, not too much, not too little. And in Sweden, they've got a lovely word for it called lagom. It's a bit like, you know, Goldilocks, not too much, not too little. And I think this is the key. So in the language of addiction, this corresponds roughly to drug effect, so emotion and withdrawal states. So the yellow arrow here in the opponent process represents the positive drug, the euphoria, energy, less anxiety, pain relief. That's pretty much why people take drugs, to, you know, to feel better, to overcome negative emotions. A lot of people that take drugs in Cape Town, a lot of the young people that take drugs in Cape Town have got an experience or a history of childhood trauma. So they actually, you know, get into the habit or get into a group that encourages them to take TIC, and it makes them feel better. It makes them feel part of a social unit that perhaps they don't get in the family environment. Here then, the red arrow represents the negative effects, so paranoia, nausea, anxiety, obviously withdrawal, needing to take more. And this represents the strength of the drug. So the more this circle happens, the more likely you're going to become addicted to the drug. And this is a nice diagram taken directly from the handout that you've got by Everett, which is basically showing a very nice way of how it's a spiral out of control. So you know, the way that a drug's addiction starts is that you may have a behavioural trait or vulnerability. So not everybody, so people in this room, if we all took heroin, for example, and I'm not encouraging you to, we wouldn't all get addicted. Some of us could say, oh yeah, that was nice, but I'm bored now. Others would crave it. So there's something about a vulnerability, an impulsivity, novelty-seeking, anxiety type trait. And in a little while, I'm going to see if we can figure out how many people in this audience are impulsive, on the impulsive side, and how many a bit more towards the control side. It's completely anonymous, I promise. And you won't be judged. But those people that have this vulnerability, then it becomes, you know, you start taking the drug, you acquire the drug, and you start choosing to administer the drug. And then it's still not an addiction yet, though. It becomes controlled drug use. So again, there's that word, control. So you're in control. You've decided to take the drug. But then, this is the crux. The habits start coming on. Pavlovian conditioning starts happening. You start getting a stimulus response. It's an impulsivity. You need more. Heavy intoxication occurs. And then it becomes compulsive. Then it starts to affect your thoughts. You start to learn that if you do this, if you go to this particular place, if you know, anybody that smokes in the audience, smoking is very tricky because you learn to associate the place that you normally smoke with smoking. So if you smoke in the car, as soon as you sit in the car, you're more likely to want to light up. And I don't smoke, but I tell people that I used to smoke when I was doing my PhD a little bit, but I didn't want to get addicted. So I used to say to myself, okay, I'm going to have one cigarette at night, at 7 o'clock at night when it's freezing in London, and I used to live at the top of a house share, which meant that I had to walk 4 floors down, unlock the back door, and then go and, you know, have a cigarette, and I couldn't be bothered. So it actually stopped me. But I allow myself to have that permission. If I really wanted to smoke, I'd have to go through all that routine. And that's the key, if any of you do smoke, to give up smoking. Don't say, I'm going to cut completely. Give yourself a rigorous strategy. And then, you know, when it gets to this phase of compulsivity, you're addicted, you relapse, you're more likely to relapse, and your executive control fails. So this is the frontal system. This is what controls your behaviour. The prefrontal system breaks down. And once you're in this bottom spiral, once you're down in this hole, it's very, very hard to get out again, but it's not impossible, is what I'm going to hopefully prove to you. So going back to Pavlov's conditioning, classical conditioning, is more associated with a part of the brain called the dorsal striatum. And this is another important key word, the dorsal striatum, which is in the midbrain. And it's dorsal means top, as in the dorsal fin, so it's the top of the striatum. And this is really responsible for habit forming. So any habits that you feel that you might have, it's because your dorsal striatum is very active. Then Skinner's operant or instrumental conditioning, this is where learning takes place. This is where you learn if you like something or want something, liking or wanting. If you learn that you like classical music, or if you learn that you like, I don't know, eggs Benedict for breakfast, this is the ventral striatum. Ventral means bottom. The ventral striatum is also sometimes called the nucleus accumbens. So these are very important brain regions. Right in the middle of your brain, your animal urges, anything, whether it be sex, whether it be chocolate, whether it be drug taking, whether it be compulsive shopping, all this need to do these things is driven by the striatum. But the problem is we all have a different kind of addiction, which is probably associated with the prefrontal cortex. Of course, the opponent motivational process tells us the positive and negative effects. And then we also have genetic and environmental vulnerability. So as I said earlier, if you've got childhood trauma or any form of trauma, even if it's mild trauma, you're perhaps more likely to want to find alternative reward substances. But these things can all explain why some people become occasional users, while others become completely addicted. So it's not definitely the case that if you take drugs, you're going to be addicted. So let's get into more hardcore stuff. So the striatum, I mentioned the striatum. Now, this is the striatum problem of addiction. It's right in the middle of your brain. This is like an egg-sliced brain, right down the middle. So this would be where the eyes are, and this is the back of the brain. And these are just 3 slices right through the middle. And this blob is the striatum, and it's actually function in the striatum, specifically dopamine. That's another key word, as you probably have heard before. Now, dopamine is the neurotransmitter that fires along, as well as other neurotransmitters, but these brain images are showing, for example, in the left side, transportation of dopamine. So the dopamine molecules are nicely busy. They're all moving around. The red dots represent how busy the dopamine is in the striatum. So it's nice and active in the healthy person, nice and active. But in the meth abuser, or user, I should say now, this is an old slide, 1 month after abstinence, the dopamine transportation is a lot lower, 1 month after stopping taking methamphetamine. And that's because there's been an upregulation of receptors. This is also an important point. Whenever you're addicted to something, the tolerance is because there's more. It's like hungry birds in a nest. They're craving more and more dopamine. And because you started taking meth, for example, more of these receptors have been formed, and so the brain needs more and more dopamine. So the reason that you can't see dopamine flying around here is because it's been essentially sucked up, taken in by the neurons in the striatum. And the last picture here, 14 months later, over a year later, and it's only then that the meth abuser's brain, the striatum, has returned to almost normality, not even quite. So it takes 14 months for them to get back to normal. So you tell a methamphetamine user to stay off methamphetamine for a whole year. It's going to be tricky. So the problem is abstinence. How do we increase that control while your brain is trying to rebuild itself, essentially? And that's the key. If you can keep on the wagon, if you can just hold on for a year, then you'll be fine. So what and where is the striatum? And maybe some of you already know this, but the red part here, so this part here, is the striatum. So you've got the ventral striatum, the bottom part, the nucleus accumbens, also called the ventral striatum, and the dorsal striatum, which is the habit-forming, the Pavlovian aspect of the brain. This is the Skinnerian, the operant conditioning. This is Pavlovian, habits, learning. These other regions are also very important. The ventral tegmental area is where dopamine gets released. It's like a big hose, and it just gets fired from this brainstem into this midbrain system. The amygdala, which is this almond-shaped part of the brain, helps us to remember what we liked before. It's an arousal mechanism. So it's almost like fight or flight, but anything that feels good, the amygdala, or also anxiety, is activated. And the hippocampus, which is connected to the amygdala, is helping you to consolidate your memory. So if you took a drug in a club somewhere, and then it felt really great, then you'll remember to go back to that club again, or whatever. And then the other very, very important part of this brain network, because remember, it's not just brain regions, they talk to each other. So it's not just brain regions, it's networks. So the prefrontal cortex is also very, very important in this story. And this is, yes? Of course, yeah. This is a really great question, because my belief, and I don't know how easy it's going to be to test this, but my belief is that you're born with a particular temperament, and that temperament is midbrain related. So however much you get aroused by your environment, and that's sort of amygdala based, you're kind of set at birth. But then you learn to navigate, to modulate your inbuilt innate tendencies through interaction with the environment. And this is sort of learning, prefrontal cortex driven. Yeah. So this is taken directly from the handout. It looks a little bit complicated. Don't worry too much. I just put it on here so that I can explain it, so that the handout makes a little bit more sense. But essentially, it's just a prettier way of explaining what I've just explained. So this is the prefrontal cortex, the orbital frontal cortex actually, which is right in the middle of the eyes, and the supplementary motor cortex, which is obviously to do with instrumental conditioning and doing something for your drug. This is the dorsal striatum, the dorsal medial and the dorsal lateral. That just means middle, and that just means side, but that's essentially the top of the striatum. And as we've established already, that's the ventral striatum, the bottom, or the nucleus accumbens, which is where learning takes place, the Skinnerian, instrumental. So when you have to do something for your drug, that's the learning, ventral striatum. And when it's habit-driven, Pavlovian, it's dorsal striatum. And then this is the amygdala, the central amygdala and the basal lateral amygdala, which just means the middle and the sides. Okay? So all of these connect, and they determine whether or not you're going to be addicted to something. Don't worry if there's too much information. I want you to go away and read this in the handout, and then we'll get more time to discuss it. And I want you to come up with questions, and please feel free to email me any questions you might have as well. So, going a little bit further, so we've talked about the midbrain and the striatum, but it connects, as I said, to the frontal cortex. So the two main neurotransmitter systems are the dopamine pathways and the serotonin pathways. I'm not going to talk too much about serotonin. It is involved in mood and anxiety and cognition. But in terms of reward, as you all probably know, it's the dopamine hypothesis. And as I said earlier, the VTA, the ventral tegmental area, releases lots of dopamine. So when you take a drug, or you eat chocolate, or you kiss your favorite beau, then it stimulates dopamine release. And this gets released like a squirt into the midbrain, the striatum, into the other areas of the limbic pathway. This is called the limbic pathway. And then a massive pathway comes up to the prefrontal cortex. Now, as I said earlier, the prefrontal cortex helps you to modulate. So you're born with this tendency, I believe, this midbrain tendency to be stimulated by certain things, or stimulated to a certain level. And then the prefrontal cortex, you learn to modulate. And this is very plastic. So neuroplasticity can occur by training, I believe, or by doing something to help increase the connectivity in this brain area. So the prefrontal cortex. Now, the most important in my research really is this part of the brain called the dorsolateral prefrontal cortex. So it's still the prefrontal. And again, neuroscience is very, very good at giving you these very hardcore terms to try and confuse you. Honestly, you don't need to be confused because it's very simple. Dorsal means, like, as in the dorsal fin, top, and lateral means sides. So you could say the top sides of the prefrontal cortex, but it sounds sexier to talk about the dorsolateral prefrontal cortex. So the next time you're in the pub or in the cafe, tell them I've learned a lot about the dorsolateral prefrontal cortex, and they'll be very impressed. But the DLPFC for short, because that's easier to say, it's very interesting because this is a brain image of the normal natural development of the brain from age 5 up to about 20. Now, what I want to point out to you here is that when the brain is fully mature, it's all sort of blue. So the green bits are lagging behind, the red is the last to develop. And as you can see here, one of the last areas of the brain to develop is the DLPFC. So, and that's why probably kids are a lot more impulsive than adults, right? Because you take them into the supermarket, I want some sweets. I haven't got kids myself, but I do see them in the supermarket, and this is why. Because, you know, the DLPFC hasn't fully developed enough to become adult-like and, you know, modulate your impulses. So this is also tricky because the majority of people that start taking drugs are those in adolescence. And also the people that are more likely to take drugs are those who are, have had trauma. So, and this also has an effect on the development of the DLPFC. So, I'm going to have to speed up a bit because I noticed that we are running out of time. And now, the lateralization of function of the DLPFC, there are slightly different functions, and this is quite important. And just to try and make you remember, the L and the R will help you remember. So the left DLPFC, take-home message is it's for future control. So later, L for left, L for later. So if you're going to try and control yourself later, as in the case, I want to stay slim in future, I want to get a degree and a good job later, you've got to engage and control yourself now, study hard for later reward. So you're thinking about controlling yourself in the future. But the right DLPFC, rather, is involved in controlling yourself right now. So if you go to a party, you haven't had time to eat lunch, and you go in the evening to a party, an academic party, and you're starving, this has happened to me, and but you want to really gouge on the food, but your boss is there, and you want to look genteel and graceful, so you have to control yourself in the moment. And that's the right DLPFC, and that's very important to remember. Okay, so quickly moving on to some actual data. So this is some of the first data that we did in London, and I just want to draw your attention first of all. I'm going to quickly talk you through this. This is actually the right DLPFC. It looks like it's left, but we're looking into the scanner. So we're looking from the feet, the person is laying down. So this is actually the right side of the brain. So this is the right DLPFC. And we compared healthy women in London to anorexic women. And we found that it seemed, it wasn't actually the case, really, but I'll explain this. It seemed that the anorexic women had a larger DLPFC than healthy controls. So we looked at this further, because normally anorexic women have got smaller brains because they're starving themselves. So we thought this is a bit strange. So we looked into this a bit further, and we found that there was an age-related atrophy, which means reduction in the healthy women as they aged. I'm sorry to say, you become probably more impulsive as you get older, because it doesn't matter, you know. But so as they got older, the healthy women, their DLPFC, their right DLPFC, started to shrink. But when we looked at the same age-matched women with anorexia, there was no age-related reduction. So what was saving their volume? So that's why the difference was there, because the healthy controls, they were shrinking, but the anorexic women were staying the same. So if it's normal for the DLPFC to shrink, there must be something that they're doing with their brains that's preventing that brain region from shrinking. So we looked at it further, and we did a nice multiple regression, and we found this lovely correlation. And there's a questionnaire that measures restraint, cognitive restraint. And the more, it turned out, the more that these women restrained themselves, and actually the heavier they were, so that the larger they felt they were, the heavier they felt they were, these were anorexic women, the more they felt the need to restrain their appetite with their cognitions, and the larger their DLPFC was. So that seems to suggest some kind of plasticity in the anorexic women, that they were using their cognitions, ruminating an OCD type scenario over and over again. I must not eat, I must not eat, I must do this, I must do that. Like a working memory type thing, which you're using your memory to ruminate on these cognitive strategies. And it seemed to increase their brain volume. So use it and it increases. So on another angle, we did a study in Sweden where we looked at elderly obese that had been obese consistently for 5 years. They hadn't lost and gained weight. They'd been consistently obese for 5 years, and we compared them to elderly lean. These were like 75-year-olds. And we found that those that were obese had a significantly smaller left DLPFC. And not only that, but they were really bad at this task called working memory. They were a lot slower. So not only were they obese, not only did they have a smaller DLPFC, they were really bad at this thing called working memory. Now, just to quickly tell you what working memory is, in the old days, when I went dancing, I would go to a nightclub and I would be dancing away, and I'd meet a lovely young man, and he'd give me his telephone number. And in those days, we didn't have mobile phones. So he'd give me his telephone number. Damn, my pen is in my pocket in my coat in the cloakroom. So I'd have to remember his number, 546228, 546228, and go across the dance floor, avoiding all my friends who were trying to get me to come and dance, to go to the cloakroom and pick up the pen and write it on my hand or a piece of paper. So to get from the cute boy to the cloakroom, I had to keep reciting this number in my head while avoiding the immediate distraction of my friends saying, come and dance, come and have a drink. And that, in a nutshell, is working memory. That's what people with anorexia do. We're bombarded with food on a daily, minute-by-minute basis almost, but yet they're able to use this cognitive rumination to avoid these external distractions, and that is working memory. And working memory is associated with the DLPFC, the ability to keep your plate spinning, to keep in mind these cognitive strategies that you want to achieve. Also in addiction, as you might expect, those people that want to try and quit smoking, so this is smoking abstinence, those that tried but relapsed, they had a much smaller dorsolateral prefrontal cortex. This is another region, the posterior cingulate cortex, which is involved, but I won't talk about that today. But the DLPFC was a lot smaller in those who tried to quit smoking but relapsed, similarly to the obese people. And this was a very recent study as well. So, and then there's very little done on working memory and the DLPFC in addiction, but there has been a meta-analysis, which means all the studies that have been done have been pulled together to see what is the most prominent brain region that's involved. And lo and behold, as you might guess, the DLPFC is associated with working memory. And the more impulsive you are, and the worse your working memory is, the worse this DLPFC functions. So the DLPFC communicates with the striatum, and the better it is able to communicate and modulate the striatum, the more willpower or control you might have. But as the gentleman said, if you're born with a hyperactive arousal system, you're going to have to really strengthen that DLPFC. But it's not impossible. You can do it. And you can train it as well. So we'll go on to that. So this is the Badley and Hitch model back in '74. I'll just quickly skirt over this because probably we've heard of this before. But essentially, this is the control. This is probably prefrontal cortex driven. This is probably temporal, parietal, and a bit of hippocampus. And then you have this sort of rehearsal mechanism. So it really fits well with this notion of rumination, of practicing, phonological loop, practicing in your mind what you want to achieve, what your future goals are. So it's the ability to keep in mind lots of plates spinning, right? So the more plates you can spin, the larger your capacity may be. So if you can keep in mind, if you can multitask, then you're more likely to be able to keep to your goals versus jumping to conclusions. So I have to say, people with anorexia are more likely to have too many plates spinning to the point where they're really hard to live with. They're not spontaneous, they're really set, perfectionistic, rigid. They've got all these plates spinning, they can't really get involved in their environment. Whereas people with drug addiction, they don't care about these cognitive strategies. They want to be involved in the environment, so they kind of jump to conclusions. I'll just give you a quick anecdote. When I used to recruit anorexic patients in London, I would go to the hospital, the Bethlem, which used to be the Bedlam actually, and go in and ask them, would you like to take part in my study? And they'd go to me, they'd look at me like this. Who are you? What do you want? And they wouldn't say yes or no. They would ask me lots of questions, and eventually I would get a recruit for my study. Conversely, here in Cape Town, I went to the drug counselling centre, the treatment centre, and I went in and I said, would anybody like to take part in my study? Yes, please. They didn't ask any questions. I could have given them a frontal lobotomy. So it's very, very different phenotype. Okay. Permission to test your brains very quickly. I know we're running out of time, but can you please find your little piece of paper here? And I really don't want you to spend too much time on this. I really want you to go with your gut feeling. Please, 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 don't worry about anything. I'm not going to judge you. But when you feel that you know the answer, honestly, I want you to hold your paper up, and I don't want you to change your mind. So there's balls in these jars, and there's either more red or more black, okay? And I want you, when you think you know whether there's more red or more black in the jars, I want you to hold up your paper. So if you think there's more red, then hold it up high. When you feel that you know the answer, and if you think there's more black, you can't know yet. Or maybe you can. Okay, but please just go with the flow and take your first instinct, okay? Here we go. So I'm going to empty the balls. Oh, you're a cautious lot. Okay, great. So keep them there. Don't change your minds. Oh, it's even Stephen. It was black. Well done. So all those people, I have to say, that decided red, you would be the impulsive ones. And the ones that waited till the very end, at least, and held at the black, we could say maybe you were sampling the environment a bit more until the very, very end. And I think it's good to be at both. I think it's nice to be impulsive sometimes, right? But it's also very good to really deliberate and not make your first response. I have to say, at this point, it's really worth reading a very good book by Daniel Kahneman called Thinking Fast and Slow. He talks about this, the fast and the slow system 1 and 2. And he mentions how you want to go with your gut feeling, but often it's better to wait and train yourself to go with the second. Okay, so I mentioned this impulsive spectrum earlier, and so this ties together the research that I've done looking at anorexia on the left side here, restriction, and impulsivity on the other with binge eating. And just to note is people that have restricting anorexia are least likely to engage in substance use disorder. So there's been a paper written about this, that something saves them, and you can probably understand now a little bit more about what, from engaging in substance use disorder. Whereas on this side, they're a lot more aroused, they're prone to aversive social situations, they're more likely to engage in alcoholism, binge eating, and addiction. And as we've mentioned, there are specific brain regions, the prefrontal cortex and the striatum, the midbrain systems that are associated with these impulsive versus restrictive traits. So, moving swiftly on to treatments. So the standard treatments then to try and improve these things. So that was the brain processes. So how do treatments alter these brain processes? Well, there's not very many brain processes, not very many treatments, I have to say, that improve addiction. It's a very sad state of affairs because relapse and attrition, that means the inability for treatment to have a long-term effect, is quite high. And I asked my colleague the other day, what pharmacology is there for addiction? And he said, there's very little at the minute, actually. So it's a real sad state of affairs. But the most well used in the treatment that has the most effect is cognitive behavioural therapy. And cognitive behavioural therapy aims to alter affect, which is another word for emotion, behaviour and cognitions, the ABC model. And it aims to alter these things about the self, the world, and others. Then there's mindfulness-based stress reduction, which also helps you to lower, or to not necessarily lower your arousal, but to strengthen your deliberative cognitive processes, that prefrontal cortex system. It's based on Vipassana meditation, which means self-observation through breathing and self-transformation. So catching yourself, having these impulses, trying to create a distance between the stimulus and the response. That Pavlovian, you see a stimulus, you want to get it. Next time you guys feel that you want to engage in something and you feel that pull, try and create a distance between the original stimulus, giving you that pull, and your subsequent response. And pharmacotherapy, which is drug-based, effective treatments are really only available at the moment for tobacco, nicotine, and opioid addiction. And in both cases, as a substitute treatment, acting at the same receptor sites, but in slightly different ways to mitigate the effects. So, methadone for heroin, naltrexone for alcohol abuse, and methadone, as I said, for heroin. So the effects of these standard treatments then, well, CBT, cognitive behavioural therapy, this is just one example, but it shows that after treatment, there is a reduction in this midbrain arousal network. So you can actually reduce, with cognitive behavioural therapy, the midbrain network, but it's probably not affecting the midbrain activation itself. As I said earlier, it's probably increasing the modulation by prefrontal cortex. So you're strengthening the prefrontal cortex, you're strengthening that hold on your innate temperament. This looks complicated, but I promise you it's not. The effects of mindfulness, this was taken from this paper, and I can give you these references, but it's saying the same thing. It's actually strengthening this prefrontal network, this prefrontal control network over that midbrain habit arousal network. So that's all this really is saying, that mindfulness increases your ability to be self-aware by changing those prefrontal systems. Novel treatments then, we have transcranial magnetic stimulation, which means, so this is a novelty, this is a new treatment. You pass an electric magnet through the brain and it actually stimulates the DLPFC to work better, which sounds very sort of Frankensteinian, but it apparently works. It's quite a good mechanism or method. Contingency management is a way to relearn new reinforcement. So you learn to get reward for other pro-social goods. So every time you stay clean, you get a pro-social voucher to spend in Pick and Pay, for example. And it forces the patient into deliberative mode, which means that slow system. That system, those people that held up the black ball, that ability to wait, to not engage in the immediacy of the reward for the drug, but to think of the future. It will be awful, to keep taking this drug because I'm going to damage my family and my health. And then cognitive training, for example, working memory. So can we strengthen that working memory system? Repeating the task, and this evokes neuroplasticity in frontal striatal circuitry. Transcranial magnetic stimulation does work. So this recent meta-analysis of 8 randomized controlled trials of nearly 200 patients found that active stimulation of the right DLPFC, remember, right now control, actually works. So the DLPFC is really important. The neural correlates of contingency management, couldn't find any yet, which is a really, really good piece of news for us, because I'm going to really embarrass her now, but my wonderful student, Lara van Noonen there, is a PhD student. She's just doing some groundbreaking work in contingency management and the neural correlates of this technique, which has been pioneered in Los Angeles in America, with very good results, and we're now the first in the world, in Cape Town, to look at the neural correlates of contingency management. Then cognitive training. So there hasn't really been much done either, but it does implicate the DLPFC. So quickly, I'm nearly at the end, I promise, so thank you for your attention so far. But some recent work from UCT. So we are based at the Department of Psychiatry on the medical campus. This is my boss, Prof. Stein, and this is the new scanner that got given or came to us last year, and it's part of the new psychiatry neuroimaging group at UCT that's really pioneering new brain imaging work in collaboration with Oxford University as part of the Clinical Neurosciences Institute, which is hopefully coming in the next few years. So it's a very exciting time here at the Department of Psychiatry. And so last year we had this, we finished the research which was related to this research question: can we learn about the treatment of substance use disorders from the neural correlates of anorexia? So this is obviously my interest, and I'm biased to see if we can do it. So does cognitive training using a working memory task improve standard treatment by lowering impulsivity and improving control in people with substance use disorder? So there's been really nothing done in this at the moment. So we are also the first to do this as well. And we're now busy writing up the data, so I'm very excited to show you sort of hot off the press data. I can send you these. The research question, in other words, quickly, so people with a diagnosis of anorexia appear to have a larger working memory capacity than most people. And this probably enables the excessive use of complex cognitive strategies to make detailed predictions about what is going on in the world. And on the other end of the spectrum, impulsive people, such as those who binge eat or take drugs, appear to jump to conclusions. This means that they probably have a less efficient working memory capacity, so they can keep only a few plates spinning or thoughts about future goals in mind. So the idea is to try and strengthen that working memory capacity. So whereas people with anorexia seem to be able to hold in mind lots of thoughts at once, people with substance use or behavioural addictions are distracted by their desires. So the big question is, can we increase working memory capacity in people with substance use disorder, or is it something that you're also born with? So we decided to try and answer this question with our brain imaging work. So who was the tick patient that we looked at? So he was on average 22, matric, educated, mixed race. Tick was his primary substance abuse, no HIV, also smoked. We couldn't have people with psychosis because excessive tick use can lead to psychosis. and they were abstinent for 2 weeks. Have I got time to show the... Can I? Okay, great. All right, let's see if I can do this. So this is just a picture of... oh, hang on. I hope I can do this. Yes, okay. Here we go. So let's see if it works. Oh. Can you help me? How do I get it to play, you know? It played before. This one. Can we press this? Move it up.
Double click on that and then press the orange triangle on the left, one of those.
This one here.
Or your left, right, wait. Yeah. Our left.
Oh. Click on. Oh, I think it's playing. Click on this one. Click on it again.
I think BRAIN has to open it in the else.
Oh, it doesn't. You know, it's just. It's actually not that exciting. I promise. Now you're desperate to. See. It's just showing them doing the task. Actually, it's. Come on. Oh, we've lost it.
Sorry.
Hey. Hang on. It's. Go up. Can I just?
Sure.
I think I know what she meant. Where? This one. It's not there. I'll tell you what, I'll send it to you. How's that? Oh, you're so desperate. It was just showing him being put into the scanner. It's yeah. Okay. Oh. Okay, I've made you all addicts now. Okay. All right. So the methodology then. So we stuck them in the scanner. We placed them gently in the scanner, I should say, and we gave them some questionnaires of impulsivity, self-control, mood. So we got them to self-report these things, and then some of the group we gave them treatment as usual, which was a form of cognitive behavioural therapy called dialectical behaviour therapy, which is a way to teach them how to reflect on their emotions. Anything you missed, by the way, if you do need to leave, I can send you the slides. We're nearly finished though. And then Curb Your Addiction, which was the cognitive training we gave to the second group. And the YouTube clip you can find on YouTube by searching for Curb Your Addiction. It's a cute little clip, you should have a look. So we found that after the training, they did actually improve. So that's the first thing. They did actually get better at this task, and I can tell you what the task is. It's just a standard working memory task. They improved their mood and their feelings of self-control, their self-reported feelings of self-control, but they didn't, the yellow bar is the cognitive change, the blue bar is the treatment as usual, but they didn't improve their desire for the drug anymore. So they still felt the desire for the drug, but they were more feeling control. They got slower in their executive functions, which suggests perseverance, and they got less impulsive, and they were less depressed. And if we look at the components of the questionnaires, the meth patients at baseline were, we called them impulsive non-planning. So this was, we would expect this, that they were impulsive and that they were not very good at thinking to the future. Those that were in the treatment as usual group without any cognitive training were still impulsive and non-planning, but they were more able to reflect, which again represents what they did in the cognitive, in the CBT. But the ones that did the cognitive training as well as the treatment as usual were still impulsive non-planning, but they were more they were persevering more, and they had more impulse control. So these were based on questionnaire correlations. And then the brain imaging findings, well, at baseline, as expected, they had reduced volume in the prefrontal cortex. So they had a weaker modulation of their stratum, and their brainstem, which is part of this midbrain network, was larger, which is what we would expect. Then we found that the training was associated with differences in these networks. Specifically, the treatment as usual, they had increased stratum, but when they were given cognitive training, and this was surprising because we thought we would have increased DLPFC, but we actually found a boost in increased volume, brain volume, in the stratum. Now, you would perhaps expect that to be associated with impulsivity, but what I'm perhaps what I perhaps think now is that it improved the connections between the DLPFC and the stratum, so that the traffic was better. So this was a healthier stratum in the end. So the neurotoxicity had actually reduced. I'm going to move on from this one actually a little bit. And then we found also that those that were more accurate on the working memory task, and this is very important, so those that were the top students in the cognitive training actually had, in just 4 weeks, increased right DLPFC volume. Remember, right is right now, control of your impulses right now. So in just 4 weeks of cognitive training using the Curb Your Addiction app, which by the way is available on the Apple Store, no shameful plugging, these meth patients were able to seemingly improve their brain volume. Functionally, and we're nearly at the end, at baseline, so before any treatment, they had increased amygdala when they were doing the working memory task in the scanner. So they were much more impulsive, and they wanted to go to the toilet all the time. It was really a nightmare to try and scan them because we'd start the scanner and then they'd press the button to go to the toilet. And then, after 4 weeks of cognitive training, we saw left DLPFC function. So the bilateral DLPFC is affected by cognitive training, but in this case we saw increased brain volume in the left DLPFC. So they're trying to do the task in the scanner with all this noise, and yet they can increase their brain function because they're really ignoring the noise and the distractions, and they're able to play this game. And the working memory game evokes what you do in real life, which is use these cognitive strategies to avoid external distractions. So it really seems to work, and it's perhaps a nice adjunct to treatment. That's just a summary of what I've just told you, which will be on the slides. So, coming to the end, promise. So perseverance is the key. That's what the DLPFC helps you to do. It keeps these plates spinning so that you can persevere for longer, so you don't become a slave to your stimulation. And it may help to increase the capacity of the limited working memory store. Neuroplasticity changes, both structure and function, appear in the DLPFC and may help patients to keep therapeutic strategies in mind for longer. So this is also important. When you're engaging in therapy, it's very hard because you're having to talk about all these emotions that you don't necessarily want to talk about, but you can persevere perhaps if you use this as an adjunct to treatment, which is what I've just said. So perseverance, not just reflection, which is what the DBT helped to do. If you have both improving your reflective abilities as well as perseverance, then you're going to be helping probably to improve relapse rates. I'm certain of it. So download our app and have a go for yourself on the website. It's 60 Rand, I think, but it goes to our research costs, so it doesn't go to us. It does go to the research. So DrSamanthaBrooks.com. So how has neuroscience helped our tic-dependent patients in Cape Town? It's created this adjunct to treatment. It seems to improve depression, impulsivity, and self-regulation. It opens up a new avenue of cognitive training research for Cape Town and South African academics that are involved in this work. It increases the likelihood of more grant funding for this research. It grows the number of South African students who conduct research, and that's particularly pertinent because we've got this new psychiatry neuroimaging group and the Clinical Neurosciences Institute about to kick off here in UCT. And we're developing brand new state-of-the-art evidence-based approaches to help strengthen adolescent brains in Cape Town, as well as a preventative measure in the future. Tali and Lara are sitting up there. I'm also going to, they're brilliant students that are continuing this work. My boss and some other students that aren't here at the moment. And a special thanks to Kensington Treatment Centre, who helped us recruit. So, for your homework, yes.
The solution surely would be to try and reach children at a younger age,
Yes.
9, 10, to build the brain to actually...
Spot on.
It's more
Catching them.
the habit that gets you back every time on the...
Spot on. You've hit the nail on the head there, because the Western Cape government are going to implement this in their Strengthening Families programme, and get kids to use it, you know, that are about sort of 9 or 10 years old. So I think that's absolutely key. And people in Sweden are using this now on kids with ADHD, and it really seems to help improve their attention. So it could also improve academic performance in otherwise healthy kids as well. So please, before Wednesday, have a read through of this. Hopefully the slides will have helped to make a very dense paper a bit more readable. And I look forward to your comments. Please do ask me or email me any questions. Thank you. Yes. Yes. Yep. Absolutely. Yeah, you can use it. It's free. You can use it for whatever purposes you want. Yeah. Yeah, so please download it, and if you've got patients or people that you want to use it with, you're very welcome. Yeah. Yeah. Yes.
There's no lecture tomorrow.
Yes, no, there is a lecture tomorrow. My colleague, yes, there is a lecture tomorrow, the same time. Dr. Mike West is going to give a lecture on treatments. And you know, the different treatments and how you can implement these for your patients. So please come tomorrow. And then on Wednesday we'll have a joint workshop together. Yeah.
Her research specialises in the role that the neural circuitry in the brain, in our brains, play in what she calls impulse control. And she's interested in using this research to try and understand, for example, problems like addiction and eating disorders. And also, she completed her PhD at the Institute of Psychiatry, King's College in London, where she learned clinical neuroimaging techniques. And Samantha is going to explain in the course of the lecture what neuroimaging techniques are. I'm not going to try and attempt to explain. I looked it up at Wikipedia, and after the first paragraph I was lost. So I'll leave it up to her to explain. Samantha also then, after her PhD, she did a postdoctoral fellowship at the Karolinska Institute at the university, at Uppsala University in Sweden. She has published very many papers, over 50 research papers in this area. She is still working in collaboration with her colleagues at Uppsala University. She's hoping that her work on impulse control in eating disorders and addiction will improve our... My voice is very... Is it working? Yeah. Hello? Hello? Okay. Hello? Can you hear me? Okay. Welcome everybody, can you hear me? Welcome everybody to this year's summer school. Last year we celebrated our 65th anniversary, so this is our 66th year. And I need your assistance, Mr. Aidy.
Oh, sorry, ma'am.
It's not loud enough. Thank you. Is that better? So welcome everybody once again. It's going to be very hot today, and I wish you good luck in coping with the heat. We certainly are facing quite a number of challenges as staff because we've been kicked out of our regular premises. They are renovating the lecture rooms in Kramer, and I hope you find the change in venue not too disconcerting and not too disorientating. I'm sure most of you have been used to being down at Kramer. Parking can be a bit of difficulty. So, yeah, we all just have to be, and especially with this heat. Okay, so let me then waste no more of your time and introduce Dr. Samantha Brooks, who is going to talk to us. Samantha is a senior researcher at the Department of Psychiatry and Mental Health.
Point of almost death in some cases, but we can learn something, is my belief, from the people who have eating disorders, particularly anorexia. So that's what I did at King's in London. And then, as was mentioned earlier, I then went to Sweden to do a postdoc to continue looking at adolescents with an early diagnosis of eating disorder. And I'm glad to be here and not in Sweden at the minute because it's minus 35 in Sweden. So a very different extreme. And then I came to wonderful University of Cape Town, and I've been here now for just over 3 years. I can't believe it's gone so quickly. Studying the brain. Working with some wonderful students. I can't see any in the audience at the moment, so they're obviously still in bed, maybe, or working on my papers, our papers. And what else do I do in Cape Town? I climb lots of your wonderful mountains. So that's me, yeah. So what is addiction? So I apologise that this is a bit greyed out here, but this is the outline of my talk. So I'm going to tell you a little bit about what addiction is, the neuroscience of addiction, the neural effects of standard and novel treatments, some recent work from us in UCT, so hot off the press work, some data that we've got recently, some brief conclusions and future directions, and some follow-up. Okay, so the title of my talk is Addiction. What can neuroscience tell us about it and how to make people better? But before we start, who the heck am I? As you can hear, I'm not South African, although I'm trying to become adopted by your wonderful country. And whenever I go home to London, I ask my colleagues and friends, do I sound South African yet? Because I love your accent. It sounds like Queen's English. And they say, no, but you do say ya a lot. So yeah. So who am I? So this is me, this little person here, 6-year-old, I think, at a party. I was completely scaring this poor little boy. I was born in Northamptonshire, in the middle of England, and in a farming community. Then I moved down to London to complete my PhD. I have spent a good sort of 10 years studying and researching the neural correlates of eating disorders, and then now in Cape Town branching into addiction. And you might wonder what is the link between eating disorders and addiction. More than you would perhaps think, but specifically my research is trying to look at the what we can learn from the anorexic brain. And the anorexic brain, and this is what I studied in London, is very good at controlling something that we all need, which is food. So they do it too well to the
understanding of the brain processes involved in cognitive control, in other words, willpower. So that people with impulse control problems can be trained to improve their self-control and ultimately lead more fulfilling lives. So, Samantha, we welcome you, and we hope we can all improve our lives.
Thank you very much. Can you hear me? Okay. Is this loud enough in the back? Yeah. Okay. If it stops being loud, let me know. Thank you for welcoming me to your summer school series. I noticed that a lot of people, when we talked about willpower just then, seem to encourage me to convince them that I'm going to be able to convince you to strengthen your willpower. My belief is that we are all addicted to something. I shan't tell you what my addictions are. But whether it be eating too much chocolate, that's my addiction, or other more harmful things. I think we can all benefit from learning how to strengthen our brains. So, without further ado, please, if you've got any questions as I go through, please put your hand up and I can answer them. And if I'm going too fast, because when I get excited about my research, I often talk too fast, so please ask me to slow down.